Now, your half-life is just the time it takes for half of the sample to decay. Okay. Um, and I think you guys eventually will do a lab with like M&Ms. I think you can use Skittles too for a half sample. Sometimes my pen writes really well, sometimes not so much. I'm thinking it's probably user error. Okay, and like I said, the shorter half-life, the um, the uh, the more dangerous it is. That's the term they use on your test, dangerous. Um, and like I said, they don't show half life on here, but let's say you have like 100-gram sample of something. Um, after one half life, you'd have 50 grams. After two half lives, you'd have 25. There's actually a like an actual formula with like fractions, and it's really complicated, and I never figured it out in order to do half life, but I've just always done it this way. Another half life would be 12.5, and then you could go on and on. And let's say each half life was like 7 years, right? So then each one of these arrows would represent 7 years. So if they asked you, how long did it take to get to 12.5 grams, or how long did it take to get to a quarter of your sample, or I guess it's not a quarter of your sample, but 12.5% of your sample. Well, let's say they did 12.5 grams. How long did it take to get 12.5 grams? You just do 7 times 3 because you went for 3 half lives, and that'd be like 21 years. If they said, how long did it take to get to a quarter of your sample, that's only 2 half lives. So then you could do 7 plus 7, or 7 times 2, you'd get the same answer. 14 years. And so that's how I've always done half-life problems. It seems a lot easier to me than the fractions and stuff. So if you need this for your labs or whatever, try this method. It seems a little easier. I honestly haven't watched the nuclear physics instructional videos for this unit, so I don't know if they do the easy way or the hard way in your